We'll be discussing topologies in a lot more detail throughout this course, but I want to introduce you to the concept of physical versus logical topologies. We've mentioned that networks have both a physical and logical topology. The physical topology of a network refers to the physical layout of the devices and cabling. You must match the appropriate physical topology to the type of cabling that you will install, which may be twisted pair, coaxial cabling, or fiber cabling as an example. Understanding the type of cabling used is important in each type of physical topology. The logical topology, however, defines the logical path that data will travel from one point to another. In the past, we had devices called hubs. These devices were connected in what was called a star physical topology, but logically, the topology was a bus. So let's look at some of these topology types. The first type is bus. In early bus topologies, computers and other network devices were cabled together in a line using coaxial cable. Modern bus topologies establish the bus in a hardware device and connect the host devices to the bus using twisted pair wiring. A ring was used by technologies such as token ring and FDDI in the past. In a ring topology, the computers and network devices were cabled together with the last device connected to the first device, which formed a circle or ring. Each device is connected to exactly two neighbors and doesn't have a connection to a third device. The physical connection used here was either coaxial or fiber cabling. In a star topology, which is one of the most common physical implementations, a central device has other devices connected to it. So a switch would have PCs connected to it in a star topology. Physical cabling these days is typically done using twisted pair wiring. In a mesh topology, every device is connected to multiple other devices. This increases reliability and provides for self-healing because of the redundant links. The physical connection could be made using fiber or twisted pair wiring. The logical topology, however, is different, as it shows where data travels to get from one endpoint to another, which may be very different to a physical implementation. Later in this course, I'm going to show you how a hub is physically a star topology, but logically acts as a bus topology. It's important in networking to not just look at the physical topology of a network, but to also view the logical topology, because that may be very different to the physical design and may affect network throughput, reliability, and scalability. One of the skills that you'll need to gain as a network engineer is how to interpret a network diagram. A network diagram captures network-related information, and the amount of information varies from one organization to another. A network diagram is essentially a map of the network and illustrates the logical representation of the devices in the network and helps clarify how the devices are interconnected. In addition, a well-designed network diagram provides information such as the interface IDs of devices, device identifiers, as well as network addressing. Common network icons that you may come across include workgroup LAN switches, routers, wireless access points, servers, end-user desktop PCs, end-user laptops, Ethernet links, serial links, wireless links, and networks, which could be used to represent the internet, an access network, or a lab network.